Today we are going to solve some numerical problem related to a freely falling body or a body when thrown vertically upward. For this, at first we must know about the free fall and weightlessness, and then I'll start numerical problem. Look at this. What is free fall? Free fall can be defined this way. A body is said to be in free fall if it is falling with the acceleration due to gravity without any resistance. And we have to remember that it is possible only in vacuum because there is air resistance which makes difference in the motion of the falling body. So free fall is possible only in vacuum. But what is weightlessness? We can say this way. Let's say this is the spring balance with which I am going to take the weight of a body. This is the measurement of the weight. Actually, we are going to measure the force with which the body is attracted towards the center of the earth. It means the gravity force acting on the body is actually vertically downward towards the center of the earth. This gravity acting on the body is the weight of that body, and it is measured by using this spring balance in such a way that when we suspend it with spring balance, then the spring of the balance stretches and it applies a vertically upward force which is called reaction force to resist the gravity force. It means reaction force is equivalent with the Earth's attraction force, gravity force. This way, weight of a body is measured in terms of reaction force. So we can define weightlessness like this. A body becomes weightless during free fall due to the lack of reaction force. Such a condition is called weightlessness. Okay, after the understanding of free fall and weightlessness, now I want to say how to solve numerical problem related to a freely falling body or a body thrown vertically upward. Look at this. These are the equations of motion we have done in previous chapters, but the same can be used to solve the numerical problem related to the freely falling body or the body thrown vertically upward. Something we have to change. V equal to u plus at. A is acceleration, but in this case, when a body is falling down, acceleration will be acceleration due to gravity. It is denoted by g, small g. In the same way, s equal to u plus v by 2 into t can be used as h equal to u plus v by 2 into t. H is the height from which the body is dropped. In the same way, b square equal to u square plus 2as can be written as b square equal to u square plus 2gh. Instead of a, we are writing acceleration due to gravity, small g, and instead of the distance traveled, the height. In the same way, s equal to ut plus half at square can be written as h equal to ut plus half gt square. Okay, now before starting the numerical problem, I want to say some important points related to numerical problem. Points to remember before numerical problem. A body is if dropped from certain height, then its initial velocity becomes 0. And its acceleration will be acceleration due to gravity, which is denoted by small g, and its value is 9.8 meter per second square. In the same way, when a body is thrown vertically upward, then what happens? Every second its velocity goes on decreasing and decreasing, and at last at height its velocity becomes 0. And when the body becomes free in the air, then it comes under the action of gravity, and so acceleration due to gravity produces on it, and this is just opposite to the direction of acceleration due to gravity. That's why its value becomes minus g. A equal to minus g, and this is equal to minus 9.8 meter per second square. Now we are able to solve the numerical problem. Let's go through numerical problem. When a body is thrown vertically upward with a velocity of 15 meter per second, number 1, how high it goes up. Number 2, how long it takes to go to that height. Number 3, how long it takes to return back to the same position. What distance will it cover when returns back? These are the questions, but very interesting. There is only one information, that is 15 meter per second. A body is thrown vertically upward with a velocity 15 meter per second. which velocity is this? It is initial velocity, because its velocity goes on decreasing and at certain height it becomes zero, final velocity becomes zero. That's why what are given here, initial velocity u equal to 15 meter per second, but a is equal to minus g, because the body is moving vertically upward and it is against the gravity, and so acceleration due to gravity is negative, that is minus 9.8 meter per second square. Other information is also here. Finally its velocity becomes zero at certain height, that's why v equal to 0. How high it goes up? If height is the question, then we can write s also. Now we have to solve an equation which contains uavs. In the equations of motion, UAVS, we have to search it. Here, UAVS is missing. Here, UA is missing. UAVS, here it is present. I mean to say, third equation we are using, and so I want to use this. We have v square equal to u square plus 2as, and if we take the value, v square means 0 square, u square means 15 square, and 2 remains same, and acceleration is g, it is negative minus 9.8 into h. Now 15 square is 225, and 2 into 9.8 is 19.6, minus plus minus here, and it is, if taken to left hand side, then we'll have 19.6 h is equal to 225, and h is equal to 225 divided by 19.6, and this is equal to 11.47959. Now we are taking just 2 digits after the decimal point, but here in third digit it is 9. If third digit is 5 or more than 5, then we'll take 1 as carryover to this second digit after decimal point. That's why we are writing answer 11.48 meters. The next question is what? How long it takes to go to that height? Time is asked. That's why I'm writing time t equal to question mark. If we have whole information u, a, v and s also, then fifth one t can be calculated by using any equations of motion, but that equation must contain t. I'm using acceleration. Equation of acceleration, a equal to v minus u by t. Here t equal to v minus u by a. If we take the value, v is 0, u is 15 and a is minus 9.8. 0 has no any meaning here. That's why minus 15 upon minus 9.8, minus minus cancel. Now when we divide 15 by 9.8, then we'll have 1.5306. This is equal to 1.53 second, because we are not taking other digit behind the second digit. Okay, now therefore t equal to 1.53 second. The third question is how long it takes to return back. What it mean? When a body is thrown vertically upward, it reaches to certain height and again it comes back to our hand. It means how long it takes to go up and come back to our hand. The time taken by the same to go to the maximum height is equal to time taken by the same to come back to our hand also, because while going up also acceleration is 9.8, while going down also acceleration is 9.8. because of the direction only it is minus and plus. That's why time taken to return back is equal to 2 times t. And 2 times t is equal to 2 times 1.53 second, and this is equal to 3.06 second. And now the last question. What distance will it cover when returns back? Distance traveled when returned back. It means when it goes up, if the distance traveled is h height, then when it comes back to hand, then again the distance covered is the same height. That's why 2 times h. So we can write 2h is equal to 2 into 11.48 meter. When we multiply, we'll get 22.96 meter. This is a numerical problem related to a body when it is thrown vertically upward. Okay, in the same way, why don't we take another numerical problem in which a body is dropped? Here only one information is given, 40 meter per second. And what is it exactly? This is final velocity. That's why we can write final velocity v equal to 40 meter per second, because when a body is dropped, then at first its velocity is 0. Its velocity goes on increasing and increasing, and at last when it hits the ground, its velocity is found to be 40 meter per second. Here, initial velocity is 0. Acceleration A is actually g, and it is 9.8 meter per second square, and height s is h. Now check it out. Here we have b, u, a and s. v, u, a, s. Where is it? In the same equation, we have b square equal to u square plus 2as. When we take value, b is 40, 40 square, u is 0, 0 square, and a is 9.8, and s we can write as h. Now 40 square is 1600, 0 square is 0, it doesn't have any meaning. 9.8 into 2 equal to 19.6 into h. Now h is equal to 1600 divided by 19.6, and the final result is 81.63265. After the decimal point, there are many digits, but we are taking just 2 digits, and third digit is less than 5. That's why we are going to ignore all other except 81.63. That's why height of the tower is 81.63 meter. We can conclude this. Height of the tower is 81.63 meter. Okay, I think today's target is achieved. Our target was to solve the numerical problem related to a body falling freely, and the numerical problem related to a body thrown vertically upward. Both are done. Now I want to stop this class. We'll meet in another class. Thank you.